I'm Kara Miller.
And I'm Rob Stoner.
And this is What If It Works? From the MIT Energy Initiative, this is What If It Works, a podcast looking at the energy solutions for climate change. I'm Kara Miller. You might know me from the public radio program Innovation Hub, which I hosted. I now write the Big Idea column for the Boston Globe.
And I'm Robert Stoner, the president of the Kendall Square Project and former director of the MIT Energy Initiative.
And today we're going to talk about how science can give rise to companies and how we can only fully achieve our societal goals if those companies and governments can work together. But first, a little story to illustrate this sort of journey. In the 1970s and 80s, 3 scientists started doing work that would ultimately, decades later, earn them a Nobel Prize. Their work was with a very unstable element, an element that easily catches on fire, lithium. But what they discovered was this. You can make a battery with lithium, a battery that, as it turned out, had some commercial uses. What uses? Well, that took a bit of time to figure out.
I think initially they're like thinking of cell phones, they're thinking of little stuff, right? Even getting them to work at all. But by about 2000, it became apparent that actually you could make a car that used a lithium-ion battery, and it would be way better than a golf cart using lead-acid batteries for sure.
That's Bill Green, the director of the MIT Energy Initiative and a chemical engineering professor at MIT.
So people started to think, that maybe this is a real thing. And some companies started manufacturing them, and you could buy them. But the performance was not as good as the gasoline cars. The cost was much higher. And so it was just a little niche thing.
And not too long after it became clear that, maybe you could use these batteries for cars, an American company started that would eventually use lithium-ion batteries to power its electric cars. The company was founded in 2003 by 2 engineers, Mark Tarpening and Martin Eberhard. But they would eventually leave, and one of its most prolific fundraisers, Elon Musk, ultimately became its CEO. Right around the time that Musk became CEO of Tesla in 2008, the U.S. Department of Energy gave the company nearly $500 million in loans to scale up this whole electric vehicle thing.
The government hadn't decided that this is what's going to happen. And it wasn't clear because nobody knew what the real prices were going to be in the future. But anyway, they gave it a try. And the Tesla example worked out well. Also in China, some companies did a nice job making some nice electric vehicles. And once those vehicles, in the last decade, those vehicles started coming out and people saw, wow, these actually do perform well. They do have good reliability. Maintenance costs aren't too high. And this actually looks like it's really going to happen. And then you could see once they get mass produced, the costs start going down because the engineers figure out more and more clever ways to manufacture them. The supply chain gets to be better for everything needed. And so that's why by 2019, we actually had a thing.
Green says this is where the rubber meets the road, so to speak. It took a long time, about 4 decades, between the time that chemists realized that you could use a form of lithium in a battery and the time when you and I started seeing a lot of Teslas.
And so maybe for more than 40 years from invention to the full-scale deployment that really affects the climate. That's the way it is right now. So I think, everyone involved, we want it to happen faster, right? We need it to be faster to meet our net zero targets. And so we'll have to figure out how can we make the steps faster all the way along the chain.
That, Green thinks, is the work ahead of us. That is the work of the energy transition, the move towards cleaner sources of energy. How do we bring scientists and universities and governments and industry together to make a 40-year process a little, or maybe a lot, faster?
I think there's like a systemic issue that at the beginning, you need a lot of different scientists and engineers trying to make the discoveries and trying to find the manifestations of them that really have a chance to be practical, affordable, attractive to people. And then you need a lot of people to work in the startup companies and the early stages of a business to develop it further and further to get it to be really good. And then you need, at some point, there has to be a consensus that this is what we're doing. And then the government policy will come and really support the widespread deployment, because all of a sudden you scale from millions and tens of millions of dollars kind of scale to hundreds of billions scale to make a full-scale deployment that's going to affect the climate. So that's really massive investment decisions. And so you need to have very low risk on those big decisions. So you need the government to be involved to sort of support the thing coming in. It has to be well demonstrated. People have to show that they like it. So it's really going to be a real market. But once you reach that point, things can happen pretty fast because the big investors then will come in because they see, oh, there's a guaranteed way to make some money.
And here's a side note. We're in a global race to produce cleaner technologies faster and better. You could say that's a win-win for everybody. But there are downsides to the U.S. falling behind, which might be happening in the realm of electric vehicles.
Chinese were willing to spend real money on it. I mean, we all owe kind of a debt to the Chinese government of taking the early risk, because it was not clear when they started investing that it was really going to work that well and going to be attractive. But they made a big bet that that was going to happen. I would say that actually we owe the German government a lot of kudos for the development of solar cells. They gave a really big subsidy for photovoltaics, and that led to the development of gigantic industry, also mostly in China. But fundamentally, that was being supported by the German government to do it, and it came to the benefit of everybody in the world that we all have cheap solar cells.
And we're going to need to come up with greener alternatives for lots of industrial processes, like making cement and steel and all the other things that make our lives look the way they do. But what if China ends up scaling up all those technologies, like they've done with electric vehicles and solar cells? Bill Green says that might not be an optimal solution.
I think as a researcher, it's super beneficial if there's manufacturing in your field, in your country. So then you naturally have people in your country who are working on manufacturing stuff. And if you're trying to make an innovation that's related to that manufacturing, you can have good communications with the people who make the manufacturing. And so I think it's a shame that the photovoltaic business all went to China. I don't know exactly the whole story about how that happened, but I think it was really unfortunate because in the U.S., we actually had a lot of the key researchers, and we still do have a lot of the key researchers in photovoltaics.
Having manufacturing in the U.S. means that budding scientists and engineers can work more closely with companies. They can intern, they can have speakers from the companies come to their classes. In essence, proximity matters. And, says Green, no matter the country, government matters a lot.
If you just have the free market, it is not going to happen, or very, very slowly, because fossil fuels are cheap. And there's no reason, just economically, there's no reason to move away from them. It's completely because we're trying to protect the climate, stabilize the climate, that we're going to do it. Therefore, it's got to be government regulation, subsidies, taxes have got to be driving it, and government investment and research too. Normally, when we have something that, I don't know, a new cell phone, we don't feel it's the government's role to play much of a part in there. They might have actually supported some basic research that led to some new kind of chip or something. But fundamentally, it's mostly the free market, and it just moves at the pace that the free market moves at, and how some people can make some money. And it works out for us because we all get these nice cell phones, right? But in this particular case, every year of delay is more years with billions of tons of CO2 accumulating in the atmosphere and the climate changing. And so it's a societal need to move faster. And so just working the old way is not really appropriate for this kind of innovation.
So yay for government, yay for the international, CO2 reduction process and the Paris Agreement. But you're sitting here running an industrial consortium at MIT, one that I used to run. Talk a little bit about how you see its role and the role of industry.
Yeah, so a very key part of this is at the end. There's somebody who's doing the gigantic deployment at the hundreds of billions of dollars scale to really make climate impact. That somebody is going to be a company. It's not going to be the government providing you electricity or selling you a car, right? There's going to be some gigantic corporation that's providing reliably the new good that you get that's now clean, and working out all the kinks of how to do that. And so the companies are definitely going to be involved by the end. And the MIT Energy Initiative's point of view is that we should start from the beginning, get the companies involved, helping to provide some of the funding for the research, paying attention to the research as it's going, and starting to see early, if suppose we have somebody who wants to do a startup company, maybe the big company wants to keep eye on it, maybe they want to make a small investment in it, then they might be ready to take it over and scale it up when the thing is really ready. And I think that that's a way we can help the whole thing along. Also, the students at MIT, most of them are going to go work for these companies that are making these innovations. And so it makes perfect sense for the companies to be interested in the development of their future workforce. And it makes perfect sense for the MIT students to want to try internships and try to check out these companies and see if they want to work for them. And so I think there's like multiple reasons why we should be working together on it. And the companies are trying, at least some of the companies are really trying to make their best plan for how they're going to do the transition. They have some amount of R&D capacity inside the companies, but most of them don't have an R&D capacity like MIT does. And so we can really help them with pieces where they don't have internal strength, or as a double check on their own internal R&D. And so I think there's a lot of ways that MIT can be beneficial to them. And of course, the companies can be beneficial to MIT. They help us to keep focusing on problems that are real, not just academic problems, but problems that are really potentially going to have real impact in the world. And they can provide some of the funding to make it happen. And so I think there's like a lot of mutual benefit from working together.
All right, I have a couple questions. One is just about the role of big companies. So we talked about the role of government in terms of like funding a lab and getting the science started. But then, we talked about with Elon Musk saying, well, this is kind of a small company, but we're going to fund this factory to see some Teslas roll off the line here and what they look like and people drive them and so on. But it sounds like you're saying, but then when you get to this point where you've got something that you need to really roll out at scale, it's going to be an Apple or a Toyota or,
Right.
ExxonMobil or whatever that has billions of dollars and like and networks all over the world to be able to actually do this.
Yes.
Yeah.
Yeah, definitely.
Okay. So then this leads me to my second question, which is people who run those companies are judged. I mean, stocks trade every day. All those companies that I talked about are traded. So, they are focused on quarterly earnings and earnings calls. And it seems to me that when you talk, even if you could compress a 45-year time transition, like with EVs, to 20 years or 15 years or whatever, I mean, you wouldn't be around as a CEO for 3 years if you didn't produce. So how do you think, how do people who run these companies think about long time frames when, I mean, their jobs are like on the line all the time?
Yeah, this is really difficult. Right? The incentive structure in many parts of our economy, and in this particular one, are like often mismatched with what the society really wants. And I see it with the companies I interact with, that some of the companies have decided, forget it. I'm just going to run for the maximum profit today. I'm going to kill my R&D department. I'm not going to worry about the future. And I'm just going to run the assets I have today and maximize the amount of money I get from them and buy back the stock or whatever I can do to make my stock options worth a lot.
Non-long-term people.
Yeah.
Okay.
This is the oil and gas industry.
Well, oil and gas, but not just oil and gas. I think all over. And inside oil and gas, there's a split. So actually, most of the companies don't have R&D anymore. And basically, that's the way they're operating. That we're just running down our assets. I think if you go to coal companies, it's even more like this.
They don't have research and development to think like, what is a new product going to be?
Right. They basically decide they're just going to cash out the company. When coal is no longer, no one wants to buy coal anymore, they're going to close the company.
Okay.
You're going to stop exploring.
They'll drill till they can drill, or they'll mine till they can not mine anymore, and then they're done. Okay.
They're done, right? And then, and they're just basically cashing out the company. And that's one strategy. But then there's other companies, the ones that come to MIT to support research, they typically are still running R&D arms. Their idea is we're going to still be a viable company after our main product is no longer bought by anybody. And so we're going to have a plan B. Plan A is we're making a lot of money now. It satisfies our shareholders. Background plan is we're making the plan B so that when we can't do it that way, we're going to have a new product and we're going to still make a lot of money with our new product and we're going to be the supplier. And we're taking advantage that we have this huge organization, knows how to do gigantic projects, has a lot of capital, a lot of cash flow, has a lot of engineers. And we think that in the future, there's going to be a need for big projects that use a lot of cash flow and need a lot of engineers. And so we'll be ready to be the supplier for that. And they're trying to explore, like, how can we actually monetize our capacity, our abilities that we have in the company but instead of selling oil, we're going to sell CO2 sequestration, or we're going to sell hydrogen, or they have a lot of different ideas of what they want to do, and the different companies are all making different decisions about this because partly, as you said, the CEO incentives are not that well aligned with the long-term stuff. So it's almost like the CIOs make their own decision, kind of free actually from the stakeholder pressures, because most of the shareholders just care about they get the dividend and the stock price goes up, right? But a lot of the CEOs feel some obligation to keep the company together as a viable concern. They're proud of their company. They have a lot of their friends or employees there, and they want it to be a running company. And they want they have grandchildren too, and they want the climate problem to be solved. And so a bunch of them are putting money into trying to find how that can happen. Those companies have a lot of capacity. So if they really do it, they can be very, very beneficial at speeding up the timelines. The deployment, if you had to start from a startup, I have a little startup. If my little startup with its 6 employees has to somehow replace, 10 billion tons of CO2 per year, it's like, there's no way, right? It's like, we're struggling to raise $10 million. I had to raise $100 billion. That's like a completely different thing, right? And so if we had to wait for me, it's going to be more than 40 years before my small company can solve the world's problems. But the big companies, if one of the big companies decides, I can see I can make some money doing this environmentally beneficial thing, they can scale it like in 1 year to gigantic scale that a small company could almost never do. And so I think we have to hope that some of the big companies are really going to do that. It's also important that in the US, we have most of the companies are shareholder controlled. But around the world, a lot of the energy companies are actually controlled by the governments that they're located in. And the governments have a very complicated set of stakeholders. And their citizens, many of them want climate change to be on the agenda. And so those companies face different pressures. And so in some countries, the same company that drills for oil is also the same company that puts in the solar photovoltaics, it's putting in the electric vehicle chargers, they're putting in the windmills. They're doing the whole thing. The government says, you're our energy company, do everything we want. And that's what they're doing. And I think putting all the companies together in one pot and just thinking they're all the same, I think is really not accurate at all.
Yeah, I think that's a really good point. But among those companies whose capital budgets are stressed because they're being pushed into these other areas, the BPs and the Shells, the Ecopetrols, their exploration budgets are declining.
Yes.
And so there's sort of facing a future in which they can't be oil and gas companies anymore. I mean, are they?
Is that because like of?
Well, they have to acquire somebody else's assets in order to be able to continue producing, because they'll eventually exhaust their proven resources.
That's just because they're getting to the end of how much oil is in those wells?
Yeah, they spend a lot of money every year looking for more and figuring out ways to get at oil that may be at depth, or maybe under a part of the ocean that's inaccessible, or in the north, in areas that are inaccessible. Try to figure out how to get it. You're quite right. I mean, in some of these companies, there's a certain amount of research going on still that pushes those boundaries, but in others, there's retrenchment. On the one hand, it's, yay for renewable energies and the energy transition. On the other hand, it's like, oh my God, we could get to a point where we either don't have enough of those things to continue running the economy as we run it now, and we face higher prices and maybe a big economic downturn, or something's going to have to happen on the renewable side to enable the transition and stuff to get expensive.
Yeah, actually, the very tricky thing of the transition is that we all want to still have transportation. We all want to still be able to get an airplane and go for a vacation. We all want electricity to come in our house. And so that's actually a higher want than our want for a clean climate, right? And so however we do the energy transition, it has to continue to reliably provide all those services that everybody relies on. And in fact, you could kill people if you screw it up. If all of a sudden you ban the trucks and nobody can bring the food from the farms, you could have a famine. There's a lot of bad things could happen. This makes it super tricky because it's like we have to maintain the existing fossil fuel-based infrastructure and at the same time build the new infrastructure that's going to replace it. And then, of course, from the point of view of people who own the different things, the economic pros and cons can be wildly crazy, right? From the point of view of the consumers of electricity in Illinois, you really might want to have a lot of solar cells. They have plenty of land there. and you could put a lot of photovoltaics out, and it might be really great for cleaning up the environment. But then the utilities might also own some coal power plants, and they're like, oh my goodness, we're losing our capital asset. We have to spend all this extra capital to buy these solar cells. And so they're like, well, then we want to raise the rates. But then the citizens of Illinois might say, wow, I don't want to pay so much money for electricity. So there's like a lot of conflicts. And I think it's the companies have internal conflicts between the incumbent technology and bringing the new one. And each of us as consumers have a conflict between that we're basically using fossil fuel technology now, and we want to make sure we keep on getting the goods that we want, but we also want the transition to happen. The only way we can conquer this is we have to do it together as a collective action. The society has to say, this is what we're doing. We're going to make regulations and taxes to make sure that we satisfy all these needs of maintaining the services that we need and at the same time cleaning them up and providing the resources needed to make that really happen. If we just say it's going to happen and we don't actually put the resources in, it's not really going to happen. It's just a statement. And if we make regulations that shut things down before we have the replacement, there's going to be like chaos.
So, Bill, you had talked before about this, but in many ways, you kind of bring together companies and academia and people in government, and you talked about the need for a higher level of urgency than we had when we were going through the EV transition. Do you really sense that people have that level of urgency, or maybe it needs to be even higher?
I think the political will, actually, I saw polling from Republican Party people that the political will on both sides of the aisle in the United States is in favor of cleaning up the climate. And if you go around the world, that's why all the countries support the Paris Agreement. Even a bunch of countries with autocrats in charge, they still signed on because they know their citizens really want the climate to be stabilized, right? And also they can see problems. They're going to have famines, they're going to have floods, they're going to have all kinds of trouble. So they can see like it's really better for our country to support the Paris Agreement. So there's agreement at that level. I think it's when you get down to the nitty gritty of, who's paying exactly for this and how inconvenient it is for me, that then you'll have people start to resist. And for people who lose their jobs, it's even more extreme, right? If you say, well, sorry, the coal mines are closed, all the people in the coal mining town are going to be really mad, right? And so we have to figure out how do we, help to compensate people, how to cover, how to make the whole transition work. But I think we have the same problem in many things, not just energy. So housing is a big thing for Boston area, right? If you talk to anybody
For the U.S., I would say
for US
the housing shortage is really acute.
It's really, So from one point of view, you can say, I think if you ask people, do you think we should have more housing? The rent should be lower. I think it'd be like 90% of people say yes.
Right.
Then you say, okay, will you allow the lot on the corner there to become an apartment building instead of being a couple of small houses? And most people in the town say, no, it'd be ugly. I hate apartment buildings. Right. Okay, so it's the same kind of thing. It's like that we agree in principle that there's a problem and we need to address it. But then when people propose specific solutions, people have resistance. And I think in the energy space where you see it a lot is about cost. So that if the replacement is cheap enough, we're cool with it. So I didn't hear anybody really complaining about the switch from incandescent light bulbs to LED light bulbs. You had to be like a crank to complain about that.
There were some cranks.
There were some cranks. Okay.
There always are. I mean,
but if you go to EVs, now you hear people a little bit more resistant. And part of it is that the EVs are more expensive right now, and it's going to take some public money to put in public chargers and stuff like that. But I think that as the price of the EVs go down, you're going to see people that today would say, "Oh, I'll never buy an EV." If the EV is $5,000 cheaper and you don't have to pay for gas, then I think a lot of people might say, I guess I said I wasn't going to buy an EV, but I think I'm going to buy it now, right? So I think the price is a key part. And it's the same thing why we have the coal power plants is 100% an economic thing, right? And so if we can get the prices of the new technologies to be close enough, then it's much easier to convince people to go along with the change. And so the engineers and the industry guys have a lot of work to do to try to get the technologies to be affordable, reliable, practical, not annoying to use. So then the society will say, okay, that sounds great. And then once the society says it's fine, then the government regulators are happy to come in and make it and require it because it's like it's requiring what people want anyway.
Yeah, I mean, there's these heroic things that are going to happen in the future. I think things like fusion, and I'm all for them, and it's exciting and very much worth funding. But if you can delay that time until we absolutely need them, and until we need to start spending money on adaptation, that is, changing where people live, changing coastlines, enormous expenditures that we're going to
Seawalls,
have to
yeah.
make. If you can delay that, it's a much cheaper, much safer transition. And so, I'm really much in favor of doing more. I think toward incremental, very near-term things than I think probably we're doing right now.
Yeah.
If you were, optimistically thinking, here's how I would script this scenario of who needs to work together and how they need to do it, what would happen?
Wow.
It's not happening like right this second.
Yeah. Okay. So I think there's a separation. We have some technologies that are really ready, and it's all about doing the deployment and working out some details about the regulations and things. So,
Right.
photovoltaics and windmills for electricity is really ready.
Okay.
And it's like, it's like zoning and permits for power lines and, and details about how exactly we're going to handle the uh, intermittency of the electrical power. So there's definitely things to work on there, but it's like more like you just put some money on it and you say, this is the policy, we're doing it. It could really
Just
happen.
more solar cells,
Yeah.
more windmills.
And I think
Go.
the EVs, it's very much like that too. It's like the EV deployment we're doing now is going to work great for people who have their own garage or their own driveway, and they can put their own charger in. And I think we're already on the way that's just going to happen, and you don't have to do anything. But if we want to get them in for all the apartment buildings and condos, and we want to, help people who can't afford the capital cost, and we're going to make sure enough chargers are on the highway so people are happy to use them, that's some more money is going to be needed, and it's going to, so there's like a part B of the EV rollout. But again, it's like we know what to do. It's like just getting people to do it, right? Then there's other ones like
Are those people in the government or are those people in companies?
well, the companies have to do it.
Uh-huh.
The government, if they set the regulation, the incentives right up, the free market will do it because the technology exists. But if they don't do it, the companies are not in a business to make a loss. They're not going to do it. So you can see with the charger companies right now that the setup doesn't really encourage them. They don't make any money on the chargers, and therefore they're not putting any more chargers in. And it's like somehow they've got to jigger the rules so that somebody can make some money running the chargers, and then they'll put them in.
Okay.
Now, partly it's like as more EVs come in, there'll be more demand for the chargers, and that will help them make some money. But I think it needs some examination about what the rules are for the chargers to make it work. And similarly for apartment buildings, you have to figure out what the heck the rules are about who puts the charger in the parking lot. And I have no idea, but it's the legislature or the town council, whoever's in charge of it's got to start working on it, because it's going to be like on your doorstep, 4 years from now. And ideally, you have the solution already worked out and you've already discussed it with all the neighbors and it's all ready to go. And if you don't, it could be 10 years in the courts. But then we have other technologies we don't have solutions for. So I'm working right now on ethylene, trying to figure out how we can replace the process that we use to make ethylene. So there's many materials that we use high temperature heat right now to make them. So cement, steel, certain types of plastics, a bunch of things. And right now we don't really have a comparably cost solution for providing that heat. So right now people do it with natural gas or with coal. It's super cheap to provide high temperature heat, burning some coal, burning some natural gas. But if you're going to switch to some other way, all the ways we have right now are too expensive or considerably more expensive. So you'd have to use very strong government regulation to force people to switch, or we have to invent a technology that's more affordable. So that's one where we're still at the point where the engineers have to figure out, like, do we have a real solution here that can work? Can we demonstrate it, convince the industry that this is going to work? And then if you can convince them, you get some demos, then the government might feel like I can impose the regulation. You have to do it. But if it's not demonstrated, they're not going to force the industry to change. So I think we have a split, and you can look through all the different technologies of where we are, and some of them really need university research by the scientists. Some of them need some engineers, maybe university, maybe national lab, maybe some company guys, but better coordination, better funding to really push it along. So I'm very optimistic about the ones where we already have the technology in hand, and I'm some of the other technologies, I can see that we're making good progress, and I'm optimistic about them. And there's some of them where we just need a lot more work to get there.
This problem is being approached systematically. I mean, just for the benefit of our listeners, I mean, it's not sort of hopeless.
I was wondering that when you said like, oh, we need a lot of heat to make steel and so on. Are like scientists all over the place, have they been sort of deployed to deal with this? Or is it just like, well, if you're interested, go check it out. But
so in steel, for example, the companies are super interested.
Okay.
And so they have their engineers working like crazy to try to find it. Like a lot of the steel making companies are still in Europe, and they got very strict regulations coming down the pike, and they got to do something. So they're really motivated. And we have university researchers who see it. But there's a lot more obscure industrial processes that don't have a big constituency for them that are all still going to need attention.
So they need cheerleaders to be like, how about this industrial process? Can we make it better?
Yeah, exactly. Yeah. And they need, some funding stream to support them to work on it. Often you need the industry to be involved to even teach you about the process so you know what you're really working on. And we, at MIT, we've done some of that, but I think there's a lot more opportunities for doing that. Part of it is we need the connections with the right companies, and the companies have to be motivated to work on that process. Some of it we need to teach the government people about the different processes, so they'll decide to make some funding streams available to work on them. But I think it's possible to do it. It's not, and the big ones of steel and cement, for example, they're two of the biggest. There's already quite big efforts. I think for steel, people have a pretty good idea how to do it. I'm not so sure about the story about cement, but they're definitely working in the lab at MIT on it, and there's some startup companies trying to do it. People want it to be simple. Yeah. They really want the silver bullet, and it's going to solve all the problems. And I'm sorry, that's not the way the world is. The world's complicated, and our economy is complicated. There's a ton of companies and a ton of people doing different jobs all over the world, and basically almost every company and every job and every person is being affected by this change. And so, of course, it's complicated. And so I think we should just embrace it. It is complicated, and we have a lot of smart people to work on it, and we just need to, smooth things out and make that work more efficient, so we can make it not 40 years, but make it 20 years. And then I think we're in good shape.
The world is complicated, but we're here to explain it to you. Bill Green is the director of the MIT Energy Initiative. He's a chemical engineering professor at MIT. Bill, thank you so much.
No, thank you. It's been a pleasure.
Thanks, Bill.
What If It Works is a production of the MIT Energy Initiative. If you like the show, please leave us a review or invite a friend to listen. And remember to subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can find an archive of every episode, all of our show notes, and a lot more at energy.mit.edu/podcasts. And you can learn more about the work of the Energy Initiative and the energy transition at energy.mit.edu. Our original podcast artwork is by Zeitler Design. Special thanks to all of the people at Mighty and MIT who make this show possible. I'm Kara Miller.
And I'm Rob Stoner.
Thanks for listening.